We're going to take a look at the, this is beta unit number 6. And if you remember, yeah, see, it just did it. So it went from 74 or 75 down to 67. Hopefully you guys saw that. And yeah, let me turn the backlight on. Maybe that'll help. Yeah, I'm looking in my monitor in the back. So what I'm doing is I'm watching this, and if you saw the field testing video, you'll see that this outside temperature is jumping around. And yeah, so it just went from 74 to 75 to 76. Now it's back down to 75. And I'm guessing pretty soon it'll probably jump back down to 67 or 69, or see, now it's down. So there is something not right here. And one of the things I noticed is I took the power supply off the back of it, the 120 to 5 volt, the 120 volt AC to 5 volt DC power supply off, plugged it in my computer, and I didn't notice this problem. So we're going to test it here. I'm going to plug it into my bench oscilloscope here. See if I can show you that the USB part of it works, which makes me think there's something wrong either in the connectors or yeah. Let me unplug this before I electrocute myself. But you know, maybe there's something wrong in the board-to-board connectors, or maybe there's something wrong in this power supply. That's what we're going to investigate. But first, let's verify that the USB is stable. Okay, because that'll tell me, you know, that the controller board's okay. It's something with the power supply that's not right. Okay, and if you're kind of wondering how these things come apart, it's, you know, once you remove that strap, that strap is only for these beta units, and that's because these are designed to be pulled apart. So this backboard just pops off like that. And you can see it's got these board-to-board connectors there. That's going into these headers. In the production models, these will be all soldered in. Yeah, so let's put this guy off to the side for now. I'll fire up my oscilloscope here. I'm sure the people that manufactured this oscilloscope didn't think I was going to be using the USB port to power stuff, but I do believe it'll work. I think I've tried it before. All right. Okay, so it's showing 76 degrees, and my wall thermostat says 74. So we're looking for this thing to jump around. As you can see, unless it's moved while I've been messing around with this fluke, this thing is stable at 76, and my guess is it probably is 76 degrees out here, or at least on, you know, around the bench here. Trying to get it as close as possible. Well, it's reading 78.4. Okay, well, that seems a little bit hot. I don't think it's 78 degrees here in the lab. But I don't know, maybe with me messing around with this probe, I'm not showing. Oh, that's because I've been messing around with it. So I tend to believe 76 a little bit more. I know it's not 81. I'll be back. I'm going to give it a few minutes for everything to settle down. Okay, so as you can see, the fluke's kind of settled down a little bit. It was, I don't know if there's wind blowing around here, or maybe it's just me talking, but I noticed it's kind of jumping around too. Just a minute ago it was 75.8. And so as soon as I turned this thing on and walked over here, it's changed. Don't know why. Anyway, we're not worried about the fluke. Believe me, it was 75 just a minute ago, or 75.9. It wasn't quite 75, but yeah. So as you can tell, this is not jumping around. So I guess the next step that we're going to have to do is look at the power supply. I plugged the power supply back into the, I have to be careful showing it to you. Anyway, just take my word for it. The power supply is plugged back into the board. I'm sorry, the controller. So we're not using the USB anymore. I am seeing that problem still with the temperature going all over the place. It's definitely not 78 in here anymore. It's maybe like 71. So yeah, you can see it was at 79. Now it's down to 77. Anyway, we're familiar with the problem. Don't need to repeat it. I do see it happening. So I thought maybe the the power supply. You really need to test the power supply with a load on it. Testing it, just on the bench without a load really doesn't show you anything. And as you can see, the thing is clean as a whistle. See how much noise we've got going on here. All right, so that's 10 millivolts per division. And the peak-to-peak noise I'm seeing right now is, well, it varies, but it's about 50 millivolts peak-to-peak. It's, as you can tell, it varies. But it's usually, whoa, that was something big. So I'm just going to call it 50 millivolts peak-to-peak, which is good within spec of that power supply. And I don't see any droops or anything like that. Yeah, see the temperature's down to 71 now. It was there it jumped up to 78, and I just moved it. So yeah, that's a problem with when you're working with mains voltage. You have to be very careful, and you don't want to blow up your oscilloscope or anything like that. Electrocute yourself. That's always bad. I have special probes for testing the AC, but yeah, I don't really know what the problem is, so I'll be back. I'm gonna think about it a little bit. Okay, so just to double check everything, I mean, the scope looked good. I think the power supply is okay. But what I'm gonna do is I have a sneaky suspicion it might be in the connector. Those board-to-board connectors, they're just headers, and maybe it's not getting a good contact or something. But just to eliminate, so where I was probing with the oscilloscope, the positive and negative leads there, I'm going to just power the board up straight through those. So this won't be plugged into AC, right? I'm just going to power it up. I have the power supply set for 5 volts, 2 amps, max current. I'm just going to power it up, and I'm gonna see if we still see that, because see if we still see the problem. Because as you remember with the USB, we don't have the problem. So we need to see, if it's a connector. So here we go. I'm going to power it on. There we go. Okay, so you can see it's not even drawing an amp yet. As the Wi-Fi pulls and logs in and does all that other fun stuff, you're going to see this current draw change. I'm sure if I logged into the website, or if I logged into the web GUI, I'm sure we'd see this thing go up quite a bit. Maybe even if I scanned. In fact, I don't know, can you guys see that okay? Probably not. So let's try that. Let's go over here. I think I still see the problem. So go to config, enter. Now watch this. I'm going to try the Wi-Fi scan. Oh yeah, I definitely kicked it up a little bit, but yeah, no problems. So okay, but yeah, I think it still has the problem. Hold on, we'll watch it for a minute. So I drop down to 76. See, it's like, according to my wall thermostat, it's like 71 degrees in here. It might be a little warmer on the bench, just because I've been sitting here breathing on it, and we have equipment running on it. So anyway, yeah, if you're wondering what I'm doing, I'm trying to probe close to where those sensors are and see what the temperature is. Yeah, so you can see, so yeah, so this is reading 77. You know what's interesting is ever since I went to the menu and hit that Wi-Fi, or pushed the button, went to the Wi-Fi menu, and scanned, you notice that our current draw went up. It went up almost 100 milliamps, and it's never went back down. So yeah, that's really starting to look like maybe a connector problem, because I guess maybe I pushed it some. But yeah, you can see, so you can see inside there. This is reading 79. This is reading 77, but I don't see it jumping around. It's kind of going in between 77 and 78. Let's see if we, oh, there, yeah, see, now it's back up to 200 milliamps. Is that because of the panel light? Oh, well, there you go. It's because of the stupid panel light. The panel light's pulling extra 100 milliamps. Okay, so now that my brain is engaged in what we're doing. Okay, so I'm going to turn it off again. Make sure you guys can still see what I'm doing. Let it sit for a few seconds here. That doesn't seem to really make any difference. I'm going to turn it back on. It's going to boot up. Okay, we're back to drawing. Okay, yeah, so it's reading 78. I'm not going to turn on the panel light yet. Hopefully you guys can see that okay. Okay, so yeah, I adjusted this. I noticed there was a glare coming off the LCD, so you guys should be able to see it. But yeah, I can see it doing it now. So it was at 79 just a second ago. Now it's down to 77. It looks like the current draw is, yeah, it's jumping between 80 milliamps and 100 milliamps. Well, now it looks like it's back to going between, oh, there it goes. Now it went down to 76 from 78. Okay. So yeah, it's still, okay, so now I'm going to turn the panel light on. So that increases the current draw. Oh, yeah, so it just went back up. So the panel light doesn't, I thought maybe, the panel light might have had something to do with it, turning it on and off. But we'll watch it for a little bit longer. Well, okay. Oh, there it goes. Yeah, see, it just went down to 66. Okay, so the panel light doesn't have anything to do with it. I'll be back. So I went ahead and pulled this off. Power supply. You can see where the wires are tied on there. I don't know if I showed you that earlier, but these are the two power pins right here. And so I'm just getting this out of the way. I went ahead and plugged some wires straight into the header there. And I'm going to see, well, let's see how many, first let's check the current draw. Yeah, it looks about the same. Let me turn it off here for a sec. And flip it over like that. Make sure nothing's touching. And turn that baby back on. Back down to 75. By the way, if you're wondering, it defaults to 75. When it first boots up, that's why it's showing 75. It just so happens, I guess that's close to the temperature in here. Oh, now it's down to 73, so, okay. Well, that didn't quite fix it, did it? Well, I guess I'll be right back. Okay, so I went ahead and soldered a couple wires on the back side of this power header right here. And basically the only thing it's doing is it's bypassing that header. You can see it right there. Yeah, so let's go ahead and see if that makes a difference. And I didn't do it on camera, but I plugged in the USB cable to see what the actual temperature is in here, and it settled pretty much right on 75 and didn't move. So, which is unfortunate because it's what it defaults to. But But yeah, it's I figured it was around 75 when it was jumping around. It feels like it in here. Okay, let's see. You see that okay? All right, let's power this guy up. That didn't help. Yeah, see, it went to 77. Now it's 70. I think it made it worse. So, well, darn. So, okay, well, that didn't work. Okay, well, I had to put this down for a couple days and do some other things and kind of think about it a little bit. If you'll notice, I've got it stable and I've got it wired to the power supply here, which you probably can't see. Let me zoom out a little bit. Yeah, so I've got it set to the power supply here, and it looks fairly stable. Of course, I'm moving around, and these things are diodes, quote unquote diodes. They're actually NPN transistors. I forget the model. I'll put it up on the video when I'm editing it. But anyway, they're very sensitive. So I mean, you see here, get my finger on that guy, you'll see. Yeah, see it? Just from me messing around with it. I was just putting my finger on it. And you can tell, I'm obviously not 103 degrees, but they tend to jump. Let me see if I can get my finger on it. There we go. I guess my finger is not going to be 98.6 degrees, apparently. But 70 degrees or what, see how it bounced down? It tends to do that, and I don't know if it's the ADC that's overcompensating, because it's supposed to be kind of a linear thing, and with me putting my finger, taking it on and off, it almost overshoots, if you will. I didn't really know that about it, but you can see it's kind of residually warm now. If I blow on it, maybe we can cool it back down. Anyway, if you remember, it was reading about 70 degrees or 71. Yeah, see, my wall thermostat's reading about 71. So it'll settle down. But the point is it's very stable right now. And I did a couple tests. I bypassed this header in here, which I showed you earlier. I thought the header, or at least I was hoping the header was going to be the problem. And then I plugged wires in there to begin with. That didn't really work, or it didn't help. Then I soldered to the bottom of this main board right here to bypass the header altogether, go straight to the board, and that didn't help. And that's what these two wires right here are. And so that got me to scratch my head. Why does the serial port work okay when powering it from over here and not from over here? So I thought, okay, well, it needs some bypass caps. Maybe it's missing a cap. So I plugged a big, okay, here it is. Anyway, it's a big Nichicon 470 microfarad cap. Not that important, it didn't work. So, but what I did, just to kind of show you, I just plugged it in and make sure I get the polarity right. I just plugged it in right there. It didn't work, right? And that was with it being powered from right here. And I could show you real quick. Okay, yeah, 75 is a default setting or something. Well, just like that. See how I jumped to 78? And now it's down to 74. So we know, and that's with the cap and the ground right there. Okay, make sure to turn this off, take this cap out, move the ground. So that was with a big bypass cap. And I also soldered a smaller bypass cap. What is this thing? A 0.47 microfarad. I put it across this 10 mic cap right there. Oh, sorry, the C110. To see if the ADC needed more bypassing, and it didn't really help. So that's when I kind of decided to sit back. I kind of looked at the drawing a little bit and the schematic and looked around to see if I could see anything. I didn't really see anything, so I decided to take a couple days and think about it a little bit and do some other things. So that's when I decided, I thought, okay, well, there might be a little bit of a pinch point in the ground plane. The only thing is I don't know why only certain boards would have a problem. So you can see here, this guy is nice and stable. This is stabilized at around 74 degrees. And I've let it sit here for a while and just kind of watched it, and it's not going to jump around. So the ground definitely works. So, and I'll have to show you on the schematic. Let me start with the power. The power starts from right here where this header is, comes down, comes along the side and goes up to this 5 volts. Right? And also, power also snakes around and feeds a bunch of other stuff, but that's for this ESP board. And the ground is just it's just going across the flood fill on the back of the PCB. And if you saw my PCB design videos, you'd know what I'm talking about. I said, okay, well, you know, maybe this trace right there is dragging down the, you know, since it's so long and it's powering it. And like I said previously, it seems to be connected to the Wi-Fi. So when the Wi-Fi, you know, pulls or does something to suck energy, that's when the temperatures start going haywire. So it's the Wi-Fi on the CSP module that's causing these little transistors, these NPN transistors, or AKA the diodes, temperature measurement devices to get false readings. So I tried to bypassing, that didn't work. And so then I thought, and of course the USB worked, which we saw previously. It's definitely not the power supply module, so that's good. I'm glad I don't have to worry about chasing down problems with that guy. So now I'm just left with the really hard stuff. So yeah, so we can go look at the schematic here in a bit. Well, actually, probably the PCB layout might be better. So, but the last test I'm going to do is I'm going to, just to make sure it's something with the ground, because I think it's something related with the ground plane. I'm going to go ahead and move the ground back over here and then solder a wire on to the +5 over here and make sure that it is a ground plane issue and not something else. It has nothing to do with the 5-volt rail. So what I'm thinking should happen is when I move the positive over here and the ground back here, is we'll still see the problem. If we don't see the problem, then it's not isolated to the ground plane, it's something else. I went ahead and soldered on a wire to the +5 volt input, and I just went ahead and moved the ground back here. Previously I had the ground here and the +5 there, and we'll go ahead and flip this back and fire this guy up. And it's going down to 74, that's good. Looks fairly stable. So yeah, if it's stabilized here, yeah, I'm gonna have to, I mean, that would kind of make sense because, went from 74 to 73 to 72 to 73. Back to 74. Okay, so we're seeing some instability. Oh, yeah, now it just dropped down to 70. So, yeah, for sure. Yeah, it shouldn't move around this much. I mean, granted, I've got a fan behind me and stuff, but you can, I know when it's stable, you saw it earlier, it's pretty stable. So yeah, that's definitely unstable. So it's definitely on the ground. And the only thing I can think of is that pinch point that I was telling you about, that we'll have to go take a look at and see if we can figure out. For the life of me, I can't figure out why it would only affect some boards. So let's go to the PCB layout. Okay, so we're here at the laptop. We want to look at the back side. There we go. Oh, before we do that, let's find out, let's identify. Okay, so here's that quote unquote diode, which is really an NPN transistor. D101 right here. D102 is over here. So we're going to be looking on the left side, and the power in is this rail right here. Let's see if I can get it to pop up. There we go, 5 VO. That's the power in. Here's the ground for it. Now, this is what I was showing you earlier. Now, I tied a ground here, ground wire, and I soldered a wire here, and I soldered a wire on the 5-volt side and on the ground side, powered it up with the power supply, and it was stable. So we know moving the input from here to here works. And that's basically what I'm doing when I plug in the USB, is I'm not powering it through here. And more importantly, that we discovered is, let me get to the back side, is the ground doesn't have to feed all the way back down through here, right? And as you can see, this backplane, the flood fill is pretty chopped up. I condensed this board quite a bit, and it could probably be improved. I thought it was okay. Apparently, there might be a problem. I went ahead and made a picture of it right here so we could draw on it. I wanted to trace out the ground path, so using a line tool. So the ground's going to come from here, and it needs to come down one of these holes. So I don't know where it's going to come down, but let's say it comes down. Well, let's see, there's no way the ground can get through here. This is completely blocked. So the only way it can go is through one of these holes and down through here. I can make 2 lines there, like that. All right. Now let's see, we're coming up from here, so it can't go through here, it can't go through here, and you can see it's kind of blocked right there. All this is blocked. Okay. So it's got to come through here. So we've got do that right through there. And then I guess like this, right? Okay, well, we've got a couple paths going through here. Well, actually, that's the only 2. Well, I don't know. It could come down here as well and go down. But as far as getting, well, let's just call it what it is. Right here, we've got a bit of a pinch point. And I don't know if pinch point is the correct electronics term for it, but as you can tell, it's pretty narrow right there. So this right here is, so all the power draw coming up this trace right here, which is, so it's a 20 mil trace. It comes all the way up to this 5-volt power pin, has got a feed back down through this right here, which is just probably a little bigger than 5 mil. Well, I don't know. It's probably, I don't know, 8, 10. Let's just say it's 10 mil. So, but, and that's okay. It works just fine, right? The problem are these transistors. I'm going back to the schematic here. So the way this thing is, the way the ADC is working right here is it feeds a voltage. And you can see that trace right there. See the blue trace, if you follow the blue trace back. So it feeds a voltage through that, and it's measuring the drop. across this transistor right here. And as the transistor warms up and cools off, the voltage drop across it changes. And those numbers are plugged into this ADC right here. So yeah, so here's the power in, and here's the return. And the return is just going through the flood fill, right? It's just coming, it's tied to this pin right here, which I'm not exactly sure why I did that. In retrospect, I think it's a bad idea. I should have just went ahead and put a via, popped a via down right here somewhere, and I don't know, maybe I was worried it was going to get isolated somewhere. To go back to what I was saying, so the return path has got to go through this pin. If we look in the bottom of it, this pin's got to come, it can't go through here anywhere because it's all chopped up, so it's got to come down. Where's our drawing at? We can draw on this guy here. Okay, so here's our pin right here. So it's got to come down to here somewhere, and then I got to go through here. You guys get the idea. and it can't, look at, see, it's even this didn't get flood filled. It got removed, which I'll have to fix in the future revs of this board. But and it's got to come, the only way it can come through anywhere around here is through this pinch point right there. And I'm not exactly sure that's a problem, but I think what this pinch point is doing, and I'm going to test this, but I think what this pinch point is doing is it's changing the potential of this whole part, because this is all isolated, and this is the only place that this pinch point here is the only place that's connecting this bottom side of the flood plate, of the flood fill, with the top side of the flood fill. And I think having this pinch point right there is causing a bit of a potential difference. Because like I said, so this has got to come down through here and then up and come through here, and then it's got to go into, it's got to feed down through here somewhere into one of these, or it's probably in one of these pins, like maybe this guy right here. I don't remember. Anyway, I think it's changing the potential, which is causing the differences in the outside temperature reading. And what I was saying earlier, if we go back to the schematic, and I just dropped a via in right above it, instead of tying it to this ground pin on the knob, if I would have just dropped a via in like right above it here, like right here somewhere, then it would have just had to come up and then go down through here, and it wouldn't have been as bad. Now, would that have fixed it? I don't know, because we still have this pinch point. I think that's causing a little bit of a potential difference here. Maybe. I'm still investigating it. I do believe this is the culprit right here. You know, if we had a nice big, let's say for example, and I was looking at this earlier, had I not put this in right here, which is going to another temperature NPN transistor right there, if this was gone, then the path from the ground would be just a nice big swath of flood fill all the way down, basically all the way down the board. You know, you would add a nice big chunk of copper all the way down, then it could have just feed it through here and up through here and up through here, and basically it would have made this side, it would have isolated the power through this flood fill. It would have just, you know, made it come down through here instead of, and it does go across the whole board, but anyway, it comes down, the main current flow would have been through here and then up through here. And I think that would have made it where we wouldn't have this problem, you know, with this pinch point. So, what's the fix? That's a very good question. Well, we know two things. One, I know if I move the power input to these two pins right here,
basically disconnect it from here and move them up here, that fixes it. All right. Or I can leave the power input here. We know that's okay, but I just have to move the ground input, if you will, coming from the power supply up here. Because what we're trying to do is eliminate the current flow through here, right? That's the problem, is the current flow through here. And like I said, I don't know if dropping a via in here would have even worked, because it's still got to come up through here and come across here. And with that current flow going down through here, it's probably going to muddy up the waters. It's going to change ever so slightly the reading on that transistor. And as you saw earlier, those transistors are super sensitive, and you can change them just by touching them, 10 degrees by touching them, right? So it's just enough. So I don't know. I know if I move the ground up here, which prevents this current flow through here, that will work too. So the fix of the version 3, in my mind, is to move the power from these pins here, power input, to these pins up here. Okay, these two right here. Like I said, I could just move the ground up there and just leave the power pin there, which when I look at it, I might. But my first thought is to clip these two pins off the power input and just solder in a 2-pin connector. To solder in a pigtail, if you will, which is basically just 2 wires and a 2-pin header connector, and just plug it into the power supply board, and then just eliminate the pins coming off this header right here, which I'll show you when it's done. But I'm thinking that's going to be the cleanest, because then you can just plug the wires in the bottom of the board. Sorry, in the top of the board. Well, yeah. So the wires will come. We'll look and see how this is going to work while we're sitting here looking at it. So the wires will come from here. This is the bottom of the board. They'll come through here. They'll probably have to come through this LCD hole, I'm guessing, to the top of the board, and then hang out. And then these two pins right here will just clip off the power supply board, or maybe bend them. Maybe that would be better. Just bend them at a 90-degree angle so we can plug our new connector in, and then sandwich these together. And then the power feed will come from here down this blue line all the way down here, and it will feed everything from here, which we know works, right? I've done that. I've disconnected this, and we know that works. All right, and the ground. So the ESP module and the Wi-Fi that's pulling most of the energy on this board, the path will be quarantined up here, if you will. It won't go down the rest of this board, and the rest of this stuff will flow through this little pinch point here. But as you know, that's not a problem. There's not a whole lot of power coming through here at that point, and it doesn't affect the transistor measurements.
Okay, so I decided to put the controller in a box. I'm using the USB port, so this is bypassing the problem. So the USB works. The temperature doesn't bounce around. The outside temperature doesn't bounce around. And I have all the probes plugged in. It's been sitting. And actually, I went to lunch and came back, and so now the Fluke is reading 67.3. But we're going to have to go to the the PC to read the rest of them. And I did this because some of these probes read fast, some of them read slow, and they read just all over the place when they're sitting outside. It can get, from the fan, from the oscilloscope, or the fan running in here, the heat comes on, the heat from the heater blowing around. So I wanted to make sure I put everything in a box, so to speak, so there's no wind, and just kind of let everything balance out. And I have the heater turned off. It's about 67 degrees in here. Okay, so let's go over to the PC and see what it's reading.
Okay, so we're back over here at the PC. I've logged into the controller. And as you can see, the chamber temp is 67. The probe temp 1 is 67. Probe temp 2 is 66. Probe temp 3 is 67. And it's showing the outside temp as being 70. And yeah, that's probably okay. That might be a little bit high. But these, it's a little bit high. I might look at that. But I'm not overly worried about it because these transistors aren't very accurate. But it should be a little better than that. I would say it should be within a degree or two, and it looks like it's about 3 degrees out. But my main point is all 3 of these and the fluke almost spot on. Both these guys, this first guy is Traeger probe, a real Traeger probe PT1000. This is the camshaft probe, and you don't know. You'd have to go on the controller and look. This might be 66.9 for all we know. It just shows I don't pass a decimal point to the web app. And this one right here is a 3-wire PT100, so this is probably pretty accurate. 67, of course, like we saw, the fluke is reading 67. And this is another Traeger replacement probe. I don't remember if I got it from Traeger or where I got it from, but it is a PT1000 as well. So thumbs up on that. Everything I'm very happy with this, except for this is a little bit high. But like I said, I'm not concerned about that. Okay, so now we've looked at the GUI. Now you can see the fluke is right, just almost smack dab 67.4. So I'm going to try to unbox this, and we can try to take a really quick look before the temperature the probes start changing. So here we go. And let's see, what do we got here? You see that? 66.0, 65.6, 66.8, and 70. 66.7 here. I'm just happy that all these guys are reading about the same, which makes me feel pretty comfortable. I'm not sure why this thermistor is reading. This is usually a pretty good probe. I've done this test, basically put all the probes in a drawer and did this, and they were all almost spot on. So anyway, and that thing is just solid as a rock. It hasn't budged from 70. So okay, so now what I'm going to do is I'm going to plug it in. I'm going to unplug this, and very carefully, without electrocuting myself, I'm going to plug it into the AC power. And I'm going to set it back in here and let it settle down, okay? So I think I'll go ahead and just set it back in here and plug it into the... Now remember, the AC power is what has the problem, right? Okay, so I've got it plugged in. I'm going to go ahead and seal it back in the box. And by the way, in case you're wondering, yeah, the fluke is these probes are all taped together like this and stuck in the box, right? So they're all taped. All the tips are even with each other, and you can see as me just messing around is changing all the temperatures. That's why I kind of let it sit for a bit. Yeah, so you can just see from me messing around with it, 67, 68, 69 outside. 70. Am I just seeing things? I don't know. I could have swore they just read 25. I think there's something wrong with my thermistor. Oh yeah, see, there it is. Yeah, 0. Something's not right. It's not getting a good connection or something. I'm not exactly sure. Because like I said, that thermistor was reading spot on there for a while. So something's happened to it. It's not getting a good connection inside there, or what's going on, but with it plugged into AC is not the time to debug it, so I'm not going to worry about it right now. I'm just going to continue on with other probes with the box testing. So okay, so I'm going to go ahead and plug these guys in and make sure I don't hit any mains voltage with it. Oops. And whoa. Let's close it back up here. Okay,
hold it down with this. And I'll be back. I'll let it sit for a minute. Well, I stuck them back in that box, and of course, you know, since I power cycled it and everything, and plugged it back in, and we've got 68, 68, 67, and 68, and 70. Man, this thing is stuck on 70. But I know it's not stuck. It's just that just must be what it's reading. That's pretty interesting. Let's jump over to the camera. Well, I can see the fluke from here. It is reading 68.5. Below 68.5, it rounds down to 68. If it's above 68.5, it rounds up or something like that. Seems to be a degree under, like we saw in the video. I don't think that something's wrong. It's not getting a good connection. Not exactly sure what's going on there. This makes me very happy. Let's go see what the LCD looks like. We're just looking at the 68 degree temperatures on the GUI. Everything seems to be reading 68. I'm gonna very carefully pull this guy out. And we got 68.4, 65.8, 68.6. So this should really be reading, oh, there's 68.2. It's kind of jumping around. And oh, you just see it went from 70 to 75. I just saw 75 or 71. So this definitely has the problem, right, that we saw with it bouncing around. Because I just saw 75 jump up. But the good news is that means that this ground plane issue is not affecting the temperature measurements of the barbecue probes. So I'm very, very relieved to see that. I'm surprised this isn't jumping around more. It looks very calm. But it does that. That's how it snuck past me, because sometimes it really jumps around and sometimes it doesn't. Like when I pulled it out of the box, it was showing 75. And yeah, everything looks pretty good. So yeah, that means this little ground plane issue is the only thing it's going to affect is this outside temperature reading, and these are also the cold junction temperature. And this is what thermocouples use for its cold junction temperature measurement calculations. As far as I know, well, in fact, I know for a fact no one is using thermocouples in any of their barbecues. I have not been asked about that. And I'm sure someone would tell me if they were using. Oh, I have to be careful not to electrocute myself with this thing, because it is plugged into mains power. But that is strange, isn't it? It's just it's off, but it's just settled down, and for some reason I don't know what's going on with our Camp Chef probe, but yeah, excellent. That means I'm very happy. So I'm confident in the meat probes, and the chamber temp probe is all good. Our outside temperature is a little askew and tends to jump around. I might do a little more testing off camera, but I think this video is going to be long enough, and I wanted to put it out there and show everyone what was going on. So I know how to fix the problem, and I know that the problem is not going to affect anybody other than a few degrees off on the outside temperature. And if you start using a thermocouple, it's probably going to be off a little bit. So I know how to fix it. I know how to do a workaround on these boards. If people want it, I don't really suggest it. It doesn't look like it's affecting anything. Well, definitely in the version 4 PCs, I'll relay it out and correct this issue. So anyway, very good. Thumbs up. It's well, let's call it a thumb sideways, because it's definitely a design layout problem, flaw, error, but luckily, it's not a big one.
Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.